All right. Well, we're probably not going to finish Unit 2, or this packet here, the Unit 2 packet. There's about 9 assignments in it, and we've been able to cover about 2 each day. And right now, we last finished number 6. So actually, this one would be number 7. Well, we'll get to 8. And when we'll get to with anything left in the packet, don't worry about it, okay? Don't worry about anything else left in the packet because as I've said before, if I don't go over it, if I don't cover it, then it's not assigned. So, well, I do want people to turn in their week 2 packets probably, I don't know, Monday next week. So if you finish your week 2 packet up till what we finished today, which is most likely going to be homework 8. Unit 2 homework 9 is going to be pretty much the same thing. It's just a little bit more of the same thing. In fact, actually, all of this remaining stuff in this unit are kind of all the same thing. It's all proofs. So let's go ahead and get back into what we're covering. All right, so just like yesterday, what we're going to do is we're going to start with our given, right? They give you a table to fill out. So you have your statements on this side, your reasons on that side, and you're going to start with your given. So start with what you have, right? And since it's your given, you didn't do anything to it. That's kind of like the way something was given to you, you know, like if somebody lets you borrow something from you, you expect it to be in that same condition when it's returned to you. You know, you don't want to like let somebody borrow a game or something back when games were on CDs, and then it comes back all scratched up. No, yeah, don't do that. So that's the way it was given to you. So we just say given. And again, it starts with given because nothing really happened to it at all. Okay, we can't really do anything with it. And I know a lot of students, they have a tendency to want to shift these up. So they'll start with number 1 being subtraction property because they'll look at this and say, all right, from step 1 to step 2, they use subtraction. But again, given is where it starts out from. And you're actually, like in this case, if we have reason number 2, that is what happened from step 1 to step 2. So again, that's all you're doing is looking at what's happening. What's the difference between those last two, the last step and this step? Okay, because once you have those, once you have those, then you put that right here. All right, I'm gonna just try my best to keep up with the attendance. I know I was trying to get all of this situated, but we don't need anybody late today. All right, so let's go ahead and look at what's going on here. So from step 1, well, it's kind of a bit of a weird one. It looks like they minus 6x from both sides. Oh, okay, I see what they're doing. Because there's an x and a y, that would mean that this is a linear equation. So linear equations, those are the ones that look like y equals mx plus b. Well, in this case, y equals 3x minus 7. So in this case, we're not actually solving anything. We're just moving things around so that we can put it into a different notation. All right, so minus 6 from both sides, and now we have 6 on this side, and it's going to be negative. So again, we subtracted negative 6x from both sides. And then from here, we still got to get that y by itself. So if you remember slope-intercept form, which I don't think we're going to be doing any slope-intercept form today, but again, as long as you're vaguely familiar with y equals mx plus b, we got to get that y all the way by itself, which means that we're going to have to divide everything by negative 2. So divide everything by negative 2. Right, negative 6 divided by negative 2, negative divided by negative is positive, and that's why we get 3x. Positive 14 divided by negative 2 is negative 7, so that's why we get that. So now it is in the slope-intercept form of y equals mx plus b. And again, we divided from here. We divided everything by negative 2. So I'm going to go ahead and go down and get to... Well, there's 2 right there, and the given is right here. It says it right there, and it even puts it on the first line. And then again, for the first one, we put given because, well, we didn't do anything to it. That's just the way it was given to us. You know, they could have made it more complicated if they wanted more steps. But it looks like in this case, there's going to be another example of them just sort of moving things around. which this one does not really look familiar to me right now. I don't know if it's supposed to mean something. But anyway, so let's see what happened from step 1 to step 2, and that goes to our step 2. So it looks like we multiplied everything by 2. Now again, I know that you're used to seeing steps. Okay, you're used to seeing steps happen. And whenever I know any teacher really, and I know I do this too, is I'll usually put like what happened, what are the steps between these two, well, steps. And let me just go ahead and just give you a quick reminder of some of the things we've worked on in the past. I'm just going to switch back over here. So here are some examples of some of the things that we've done. See, you can see that I'm marking off here plus 20 to both sides. Let me go down a little bit more. And you can see the orange lines are what I'm working on. And we're used to seeing that. We're used to being able to do that. Now, if it helps, what you could do is work it out on a separate sheet of paper. So by working it out on a separate sheet of paper, you can see your steps. Because here, they're not going to have the steps, right? We have to look at what's going on. So it looks like they doubled everything. So they used multiplication property to times everything by 2. And that's why we put multiplication property. Now from here to here, let's see what happened. It looks like nothing happened, right? It looks like 2m, a plus b, 2m, a and b. All right, and here's where it really pays to look closer because you can see that this a was on the right side. Now it's over on the left side. So what happened to it? We had to subtract the a from both sides. Now again, I'm not really sure what format or anything this is supposed to be. Maybe it's supposed to just be like, I don't know, something different. Or maybe that's the point, is that it's not supposed to be anything and we're just supposed to get used to moving things. Or maybe the directions of for this problem might be solve for b. And now we're just trying to get b by itself because now we have b, m, and a. So those are 3 variables. And sometimes in math, it is like that. You don't get any less steps, right? So with the problems that I just got done showing you, every time you do something, there's less and less steps. There's less and less things going on in the problem. But in this case here, everything is just being moved around. We started out with 3 and we ended with 3. Anyway, we subtracted a from both sides. And then from here, it looks like they just flipped both sides so that b is still by itself, but now it's on the front side. And that's usually what you do with algebra problems, is that you would put them in a way so that they have the variable that you're looking for go first. Okay, so let's go ahead and move over here. And this given here is a little bit different than the other ones because we have a given, f plus g equals k plus 7, and now there's a comma. So that comma tells us right there, it stops. Right, just like a comma in English, like when you're writing something. You know, I went to the store, I got Doritos and Hot Pockets. Or if you have 3 items, you would use a comma. So you'd say, like, I went to the store, I got Doritos, I got Hot Pockets, and I got soda. All right, between some of those words, you'll have commas. And that just basically breaks it up, because now they're giving us another piece of information, and that is k is the same as f. And they want us to try to get g equal to 7. So start with our given, and again, stop right before that comma, because this k equals f is not needed. So what we're going to do is we're going to put it on the second step too. So these are 2 givens. We're given this statement and this statement. So 2 givens. And okay, so what happened between these 2 steps to step number 3? Well, it looks like they replaced, remember what they said, k and 7 are the same thing. So they take out k and replace it with f. And that would be substitution property. So they substituted k equals f and took out k, put in f, and now we have an f where the k was. From here, we're going to subtract it. So take out the f from both sides, and now we get g equals to 7. So that one was a little bit of a tough one, had a lot more stuff going on with it. Now, I think, if I remember correctly, when I was talking to Mr. Moreau, they said that this was the thing that most students had issues with during the lessons, during the normal geometry. And I didn't really talk a lot with Torres San Jose or Kodagiri. So I'm not really sure what we need to work on with everyone else. And sometimes even though you have the same thing like geometry class, sometimes they can come out to be a little bit different. All right, I'm gonna go ahead and go down here. I'm gonna just see what's ahead. And we're gonna do these next 2 pages and then we'll go ahead and stop there for a while. So I'm going to move down to here. And it looks like we're given quite a lot of givens actually. So we have P equals 3Q, that's one of our givens. P plus Q equals R, another given, and R is 20. So it looks like we have a lot of stuff. We want to be able to prove that Q is equal to 5. So those 3 items are all given, so we're going to put them in like that. Now, how did we get to step 4? So remember, if you want to get reason number 4, we have to ask ourselves, how did we get to number 4? Well, it looks like they substituted it in because R is 20. They took out the R, replaced it with 20. So P plus Q is 20. And this is, looks like they used transitive properties, is what they're saying they used. That one's a bit of a confusing one because I would have imagined that would be substitution because they take out R, right? That's the R, take it out, put in 20. And then they would use substitution again. I guess in that case, if there's ever something like this, where the answer key says something different than what you could make an argument that this would have been a substitution also. I'd probably accept that, but sometimes I'd have to look it over. Sometimes it's just a little thing and it wouldn't make much of a difference. But in this case here, since I noticed that one, I'd probably mark it somewhere saying that, yeah, you could also use substitution property. But I think what they're trying to do is they're trying to get all 3 of these linked together. Anyway, moving on. So number 5, substitution property. Now here, again, P plus Q equals 20. But if we look here, P is also the same as 3Q. So take out P and put in 3Q. So now that one's definitely substitution without any doubt. And anytime you do something on both sides, like in this case here, see how I have 3Q and Q together? Well, those are like terms and they're on the same side of the equal sign. So since they're on the same side of that equal sign, we would say combine like terms, but in this case, we just say simplify. So anytime we add or subtract or divide or multiply or do anything with numbers on the same side, we just say simplify. If it's not any of those other properties that we covered yesterday. So remember yesterday we covered like 9 properties. We also have some other things like the theorems and postulates that we covered too. So those are all going to be something that you could use for reasons. Okay, so now I have 4Q equals 20. And then we just divide both sides by 4, right? So divide this by 4, you get Q. 20 divided by 4, you get 5. So that would be division property. And I'm going to go ahead and scroll on down here. And as always, I'm going to give you about a minute or 2 to try to get you to write that down. Oh boy, like I said, I'm not feeling too good today, actually. I must have eaten something bad yesterday. Or sometimes you can get it from something else. I have no idea what it is yet, but I'm kind of feeling sick. I got a headache. I got a fever. I don't know. I had chills last night, but I don't feel anything now in that. But mainly I have stomach problems, so I'm pretty sure it's something I ate. And they took my temperature when I walked into the building, and they didn't see anything. Well, didn't know. I mean, if I had a fever or something, then that would mean I was definitely sick with something like stomach flu or something. But like I said, I'm pretty sure it's just something I ate. It's not sitting well with me, although it's been like that since yesterday actually, and it's still going on. So I must have really eaten something that just my stomach really just doesn't like. So I'm not feeling too good today. I was thinking about calling out, but then like this being a summer course, I don't know how they're going to take that. You know, they'll be like, oh, we're we're just gonna take your pay away or something. I have no idea what they would do. Or I don't even know if I could use my normal leave. But I'm feeling a little bit better now. So I'm gonna go ahead and scroll back down. Hopefully you got number 4 and we'll move on to number 5 now. Actually, my dad got me some chicken yesterday, so I think it's actually something at KFC. Because I thought it was something else. I thought it was something I got from Bash's. So if you eat KFC, just watch out for what's happening. I don't know. But then KFC always has a really long line. Like every time I go there, there's like 8 cars in line or something. And I think maybe they just skipped a few steps in the cooking to make sure they got them out on time or something like that. I don't know. Oh. All right, let's keep going. Given, so we have 2 givens, 2x plus y equals 4, and x equals y plus 5. We want to prove that y is equal to -2. So this is what we call a system of equations. So we have 2 equations, right? And you can see them right here. Equation 1, equation 2. And what we're going to do is we're going to try to take one equation and put it into the other. When we do that, when we take one equation and put it into the other, well, that is literally called solve by substitution. So that's what well, once we write down our 2 givens, see how we have this x by itself. X is the same thing as y equals 5, or sorry, y plus 5. So what we did was we take out that x, take out the x, and then take the y plus 5 and put it into the other one, the one on top. Let me see if I can, maybe it'll be a little bit easier if I just draw out what happened. So again, take this y plus 5, and we're going to drop it in right where this x is. So when we say substitution property, 2x plus y equals 4. That's what we have right here. But instead of x, we took out x and replaced it with y plus 5. Now this is something that you would have covered in Algebra 1, which normally I would expect students to kind of recognize that and be like, oh, okay, I've seen this before. But the question, well, the whole thing now is that everything's all different. You know, I don't know how your Algebra 1 teacher was. You know, I don't know if you were in that last year, and because of that last year thing with all the stuff going on, and you know, maybe you forgot it. Maybe your teacher didn't spend a whole lot of time on it, but that's what's going on. So it might be familiar. But anyway, now that we have both equations put together, we eliminated x. So we're going to start solving it. So first thing is, since I have this 2 on the outside of this group, I'm going to go ahead and multiply both of those things by 2. So 2y, and then 5 times 2 would be 10. So now we have that. I have a y here and a y here. So since I have 2 y's, we call that simplifying. So we're going to go ahead and simplify because it's the same thing on both sides. Again, anytime you just straight up add or subtract, multiply or divide 2 things on the same side or multiple things on the same side, we just say simplify. Now, since my y is on this side, the left side, I want to get rid of this 10. So minus 10 from both sides. 4 minus 10 would be -6. And then since we minus 10 from both sides, that's why we got subtraction property. And again, I know this is sometimes confusing, and when I taught this a couple years ago, this was one of the big things that students would always miss out on is division. I'm sorry, number 7, step number 7 is from what happened from 6 to 7. So how did we get to step number 7? So again, that reason goes, how did we get to that step? How did we get to that statement? Well, okay, so from here, we have 3y, no more 3. So we would have divided both sides by 3. -6 divided by 3 would be 2. So that's why that's why that 3 is gone now. And that's why this has been divided by 3, because we divided both sides. All right, I'm gonna go down. And that'll be it for this page here. Looks like we got some short ones, but then number 7 looks like it's got some fractions in it. Okay. Oh, stomach. I don't know if I could just, I'll have to work something out. Oh, to do later. All right, hopefully you wrote some of this down. All right, let's see what we got. Given this, it looks like pretty much what we're doing is we're just turning this into that, right? Because we have two x and y, but then when in our proof, we have x and y again. So nothing really happened in that case. So given here, that's our given. We only have one statement, so we only have one given. Addition property, so something was added here. So it looks like they added 10x to both sides. And it looks like they're trying to, again, make it into slope-intercept form. They're trying to turn it into y equals mx plus b. So that's why we move this 10 over to this side. Well, actually, in this case, no, that would, well, it would be close to standard form. Standard form is ax plus by equals c, if you remember your Algebra 1 stuff. Although that's not technically fully in standard form. Anyway, add 10 to both sides, and then we have to divide -2 into everything, right? Everything gets divided by -2, so that's division property. All right, next one here. I know what this one is actually. This is a conversion of Fahrenheit to Celsius. Actually, yesterday, if you remember, we were working on one problem, and it was talking about like, well, something like 25 degrees or something is freezing. I don't remember I don't remember exactly what it was either. All right, so F equals 9/5 C plus 32. So it looks like in this case, this is in Fahrenheit, and we want to make it so that it is in Celsius now. All right, so let's go ahead and put our given down here. We're starting from here, trying to make it look like that. So trying to get that C by itself. So there's our C, which means in this case, we got to get rid of this 32. So since it's a plus 32, we're going to minus 32 from both sides. So minus 32 here. And now C is almost by itself. All right, so that was subtraction property. Now what happened from step 2 to step 3? All right, so the fraction, see there's a fraction on the C, 9/5. Now in this case here, oh gosh, this one would be a good one to do on a, this one would have been a good one to do on a, like, go over it together sort of thing. But what they did was they they times everything by 5/9. Times everything by 5/9. So if you times it by 5/9, it'll cancel this fraction because that's the reciprocal, right? The flip of that fraction. And that gets rid of the number on the C. So now C is by itself. Now we do have 5/9 on this side here because we're multiplying it, but we have to also group it too. So don't be afraid to group it. And then from 3 to 4, all they did was switch the sides so that C is first and F is, well, over here. So now we have this solved for C, and that's how you convert something to Celsius. So now we would know what the Celsius is. You know, I should look that, I don't know, I should play with that a little bit. I don't know, just for me. Because again, yesterday I was talking about how I don't know Fahrenheit and Celsius. So I kind of know one or the other. You know, I think as Americans, we're usually working with Fahrenheit a lot, and then when you're watching like TV or something and they mention something in Celsius, then it's like, what happened? All right, so here, given x plus y equals z, so we have our first given, second given, w plus v equals z, and that's our second given statement. And it looks like we have another one here. Now what they did is, see how this one is equal to z and the next one is equal to z? Well, if they're both equal to z, you can put them next to each other. So x plus y equals z, well, there's x plus y. W plus v equals z, well, there's wv right there. But where did the z go? Well, we know the z is the same thing. We're talking about the same thing. So in fact, again, we just put these two together. And we also know that y and w are the same thing. So that's one of the other givens. Now you could have put this given here and switch these two, I think, again. Sometimes you can switch them. Sometimes you can do it in a different order and you will still get the right answer. So in this case, yeah, you could have switched steps 3 and 4 and you would have gotten the same thing. But anyway, since we now know that w and y are the same thing, let's go back to number 3, step number 3. Take out the y. I'm sorry, well, which one would be better? It looks like we would take out the w actually. Take out the w and replace it with y, which is what it looks like they did. I guess we could also replace it with w, but we want to prove that x is equal to v. And in fact, actually, I think if you did replace y with w, it would still work out because you would still have to subtract w from both sides. So since here we have x plus y equals y plus v, well, let's just subtract y from both sides. And that's why we use subtraction property to get to number 6. And that's it for this one. We'll do one more page and then I think that's it. So I move down. Yeah, and then right there, that's homework number 7. And again, this one is a particularly difficult lesson because there is some stuff kind of going on that we didn't really cover before. So I'll give you a second or two to write that down. Okay, and I'm gonna just update my attendance. I'm a little bit late on it. I should have checked it a little bit earlier. Okay. 4. Missing 4 of who should be here. I'm gonna have to start making some phone calls today. Actually, they said that they were going to start doing attendance another way. I mean, it doesn't have anything to do with you, but they were going to say that, oh, we should turn in attendance, during certain times. Actually, I have that note somewhere. So we're supposed to do like an attendance roster and mark down who is late, who's here, and all that stuff. Oh well, like I said, it doesn't have much to do with you. So I'll wait till the break to go look for it. All right, anyway, let's get this done. So looks like we're given 2 givens again. So I have 1, and that's our first one here. And our second given is here, so that's going to be our statement number 2. And we also have a third given of Q equals R. And again, sometimes when these look really long, they can be kind of scary or intimidating, and you're like, I don't want to work on it because it just looks like there's so much stuff. And this one seems very similar to the last one. Because if you look here, this is equal to 25. So P plus Q is 25. And R and S are also equal to 25 as well. Now, since we know both of these come out to 25, we know that both of them are pretty much going to be the same thing. They might have different numbers. Just as an example, I have no idea what these numbers are supposed to be. But we could have something like 16 plus 9. And over here, we'd have 12 plus 13. Okay, we don't know what these numbers are. But whatever they are, they add up to 25. And that's kind of what a lot of math and algebra is just sort of kind of jumping from one step to another, using what you know. All right, so let's put them together. So P plus Q and R plus S, again, they both come out to 25, so we're going to take out the 25 and set them equal to each other. Now, the other given that we have here is that Q is equal to R, so we're going to substitute out Q and put in R. And what that allows us to do is that we have 2 R's on both sides. Well, 1 R on both sides, but 2 R's all together. Right, so we substituted it in. Take out the Q, put in the R. That was substitution. Now, since I have an R on each side, if I minus R from both sides, well, R cancels, P equals S. And that's how we got that. So that's it for that. All right, so let's go ahead and get to the next one. All right, I just got an email from a student. So actually, I was talking with the student before, so okay, well, I'll worry about that in a minute. We're almost done with this. I'm gonna go down. We only have 2 more to go, and then we'll be done for, well, for this lesson, of course. We'll have the other one at, what was it, 10:30? Oh, 9:45 to 10:30, okay. It's a good thing I wrote it down on the board so now I can see it, because otherwise I have to keep looking for it. All right, so what do we have here? Given, so we have, okay, that's quite a long given. 2e plus 10 equals 16 minus 2h. We also know that e equals f minus h, so that's the second given. So put those 2 things in there. Again, they're separated by commas, so we need to prove that f is equal to 3. So see how we have e by itself? E is the same thing as f minus h. So take this f minus h and plug it in where e is on the first one. So where e is, I'm going to put a parenthesis and then drop in f minus h. Then from here, it looks like we're just going to use our basic algebra to get f by itself now. So multiply both of these, so 2f, 2h. Okay, that would be our distributive property. So we distributed 2 to both of those. And again, for how did you get statement 4? That's your reason on how you got statement 4. And for statement 3, how we got here was we substituted them. So anyways, after distribution, let's see, how did we get rid of this? Okay, so I guess we're trying to get rid of, oh, there's a 2h here and a 2h there. Well, actually, they're both negative 2h. So it looks like they added 2h to both sides, and that actually canceled it out. So now there's no more 2h's anywhere. So adding 2h to both sides. All right, and then from step 5 to 6, what's our reason for 6? Okay, so let's see. How did we get to 6? Looks like we minus 10 from both sides. So by minusing 10, 10 cancels over here. So now I have nothing on this side with regular numbers. 16 minus 10 would be 6. So that's how we got here. And then, we subtracted 10 from both sides. So that's why we use subtraction property. So our reason number 7 is how did we get to statement number 7? Well, looks like they divided both sides by 2 because again, that's what most people would do when they're working with something like this. Just divide both sides on the last step. And that would be our division property. And I'm going to go down here, and this will be our last one. We'll take a break again. Ooh. And like I said, it's kind of a shorter lesson today, which is good because I'm not feeling too good today. Oh, I'm supposed to be going to Phoenix this weekend, and I hope I feel better. Nothing worse than going on a long road trip when you're not feeling too good. All right, let's get that last one down. So it looks like we have a given. A minus 2b equals 8. And it looks like they took care of something already. And again, you don't have to follow these exact same steps. I think what I would have done was I would have put the other given here, kind of like what they usually do where they put the 2 givens next to each other. But for some reason, it looks like they added 2b to both sides. Or yeah, added 2b here, and that 2b cancels on this side, but it appears on this side, so now it's on the other side of the a. Then we bring on our other given. Oh, okay, so they did that because they want to solve it for a, so now a is by itself. So we're going to use the substitution property. Again, take out this a right here and replace it with 2b plus 8 because now we know that they're the same thing. Okay, and that's the substitution property. It always happens that same way. So it is like a way of solving problems over and over the same way again. So take out a and replace it with 2b plus 8, and that's substitution property. Since we, excuse me, since we have a parenthesis, we're going to multiply both of those by 4, our outside number. So 4 times 2b, 4 times 8 is 32. And that was distributive property. So we distributed that. So now there's no more parenthesis. Combine our like terms. So it looks like we have some numbers on the same side, right? Because we have an 8b and a 3b that are on the same side. So 8 and 3b, put those together, you get 11b plus 32 equals 21. 11b, and then let's see what happened here, subtraction. So it looks like we subtracted 32 from both sides. Subtract 32 and you get 11. Negative 11 here and 11 there. And then divide both sides by 11. So since we divided both sides to get to step 8, we use our division property. Okay, so, all right. Let's see, I know I was talking yesterday about some of the attendance and some of the, because I made some phone calls to people, making sure they show up to class. But one thing I didn't really talk about yesterday was grades. So if you remember last week when I was talking about how grades would be done, I was mentioning that what I would like to have done was keep your score from the spring. So you would basically be building on what you learned from the spring. So if you already did this assignment, then you wouldn't need to do it again. But there's a lot of problems with that, and that is that there are 3 geometry teachers and they all teach slightly different things. I know some of them use the textbook, some of them use this thing here, which is actually where I got this one from. I got this from Mr. Moreau. But it doesn't always move from one to the other. So I can't just take this and translate it to that. And during that meeting we had yesterday, it sounds like they want to do an average. So just a quick example. Actually, I'm going to move over to the writing board. And again, I'm not sure exactly how they're going to do it because there's a couple of different ways that you could do this. So let's say that you got a 40% in your last class. Okay, in the spring you got a 40%. Well, if you got an 80% now during the summer, well, we would just have to add them up and divide by 2. So add up 40 and 80, you get 120 divided by 2. So your new score is now a 60%. So it would go something like that. And that's kind of what I'm understanding from the grading process here, is that it's going to be an average of your 2 grades. Now, it's not a perfect system. In fact, there's a couple of things I can see that are wrong with it. But I think we're going to adjust it as we go along because, I don't know, the math doesn't really check out on that. So, yeah, in a way, your score from last spring still kind of matters. Okay, but not as much as you might think. Anyway, I'm going to go ahead and get ready to put a stop to this, and we'll do our student independent learning after this